Bismillah ar-Rahman ar-Rahim. In this video, I will talk about weighted mean. Recall that from previous lectures that the formula of the sample mean the arithmetic mean is given by x bar equal summation of xi divided by n. This formula for the sample mean assumes that all observations, all xi have equal importance. However, in some applications, certain observations or certain data point in a dataset may be considered more important than others. For example, suppose a student received a score of, let's say, of 75 in English course, let's say English 1, and English 1 has a credit hour of 3. And a score of 93, let's say, in a statistics course. And the statistics course has also 3 credit hours. And in biology, the student got a score of 88, and the biology course has weight of 4 credit hours. Finally, let's say the student got a score of 76 in the math course, which has a weight of 2 credit hours. In this example, biology, as you see, has or is considered more important than the others. It has 4 credit hours, while math course is considered less important than others. You might try to find the mean by using the formula x bar equal summation xi over n, which is equal 75 plus 93 plus 88 plus 76 divided by 4, and the answer is 83. But not all values are equally represented, so this 83 is not a precise answer for the mean average, or for the average of the student. So we need to take into consideration the weight of each value or of each score. The type of mean that considers the weight of each value is called the weighted mean, and is denoted by x bar w. The type of mean or the formula is given by summation of wi xi divided by summation of wi, where the numerator is obtained by multiplying each value xi by its weight, WI, and then adding the products. Let us apply this formula for this example. So first we multiply 75 by 3, then we multiply 93 by 3, we multiply 88 by 4, finally we multiply 76 by 2, and then we add these products. So in our example, this is equal again 75 multiplied by 3, the weight is 3 and the value is 75, plus the weight is 3 multiplied by the value which is 93, plus, and for biology we have the weight is 4 and the value is 88, plus for math course we have the weight is 2 and the grade is 76. We divide by the sum of the weight, which is 3 plus 3 plus 4 plus 2, the total credit hours. So this is equal 1008 divided by 12. So finally this is equal 84. So this is the weighted mean for the scores. Let us see some more examples. Here we have example number 1. An instructor grades exams 20%. Term paper 30%. Final exam 50%. A student had grades of 83, 72, 90 respectively for exams, term paper, and final exam. So we need to find the student's final average. It is not right to just sum 83 plus 72 plus 90 divided by 3. This is not correct. So you need to consider the weight for each score. The exam, the 83 has weight 20%, 72 has weight 30%, and 90 has weight 50%. So let's say we have x1 equal 83, x2 equals 72, x3 equal 90, and we have w1 equal 0.2, w2 equal 0.3, and w3 equal 0.5. Now the weighted mean x bar w equals summation of xi, or let's say first wi times xi divided by summation of wi. So here we have summation of we have 83, or let's say 0.2 multiplied by 83 plus 0.3 multiplied by 72 plus 0.5 multiplied by 90 divided by 0.2 plus 0.3 plus 0.5, which is 1 or 100%, the total grade. So the answer is 83.2. This is the final average of the student in this course. Another example here. An instructor gives 4 one-hour exams and 1 final exam, which count the final exam, which counts as 2 one-hour exams. Find a student's grade if she's received 62, 83, 97, 90 on the hour of 1 hour on the 1 hour exams and 82 in the final exam. So we have, let's say, 4 major exams, each of 1 hour exam. X1 here equal 62, X2 equal 83, X3 equal 97, X4 equal 90, and in the final exam, which is X5 equal 82. The weight for the final exam, of the weight counts as two 1 hour exams. And let's see, W1 equal 1, W2 equal 2, equal 1, W3 equal 1, W4 equal 1, but W5 equal 2 because the final exam counts as 2 1 hour exam. So now the weighted mean x bar W equal just summation of Wi xi divided by summation of Wi. So the answer will be just multiply 1 times 62 plus 1 times 83 plus 1 times 97 plus 1 times 90 plus 2 times 82 divided by the sum of the weights 1 plus 1 plus 1 plus 1 plus 2. The final answer is 82.7 up to the first up to 1 decimal place. Okay, next, see example 3 here. A manufacturer has 50 employees. 15 are paid $5.25 per hour. 25 are paid $5.75 per hour. And 10 are paid $6.3 per hour. We need to find the average wage for all 50 employees. So you see here the weight for each. This payment 5.25 is paid for 15 students, and this is paid for 25 students, and this value is paid for 10 employees. So the average wage for all 50 employees is just, this is similar to the combined mean. In fact, this is equal x bar W equal 15 times $5.25 plus 25 multiplied by $5.75 plus $10 multiplied by $6.3 divided by 15 plus 25 plus 10. So this is equal the answer is 5.71. This is the average wage for all 50 employees. I will leave this example for you as an exercise. So we stop here and see you in next lectures or next video, inshallah.